Welcome back to the deep dive. Today, we're doing something a little different. Usually we take a stack of articles, maybe a new book, and we synthesize it for you. But today, today we have a stack of documents that feels heavy.
Oh, it is heavy.
Hmm.
Physically and intellectually.
Right, physically heavy, but I don't just mean the page count. I mean the ambition inside these pages is so massive, so arrogant, and honestly, so potentially revolutionary that it's a little terrifying.
It really is. I mean,
Yeah.
I've been reading physics papers for 20 years, and you develop a filter. You learn to spot the incremental stuff, that we measured this slightly better papers.
Yeah.
And then you have this is not incremental. This is a complete demolition job.
We are talking about a theory that claims to finish the work that Albert Einstein died trying to solve. A theory that says the chaos of the universe, the messy particle physics, the confusing dark energy, it's all just...
Geometry.
Exactly. It's all just geometry. It's a bold claim. But before we get to the math, and we will get to the math, but we're going to take it slow, I want to set the stage for you.
Right.
Because to understand why this matters, you have to understand the dream, the eternal dream of geometry.
Right. And this goes back way further than Einstein. This is the oldest hope in science. If you go back 2,500 years to Pythagoras, you find this almost cult-like belief that all is number.
All is number.
Yeah, they believed that if you stripped away the dirt and the fire and the wind, the universe underneath was made of perfect triangles and ratios.
Which sounds nice philosophically, but then physics got messy.
It got very messy. Fast forward to the 1950s. You have Albert Einstein at Princeton. He's the most famous scientist in the world. He's already revolutionized gravity with general relativity.
Right, showing that gravity isn't this magical pulling force, it's just the curvature of space-time.
Exactly. It's smooth, it's elegant, it is geometry.
But then there was the other physics.
Quantum mechanics, the bad boy of the physics world. I mean, it worked. It explained atoms and particles perfectly, but it was ugly. It was probabilistic.
Things popping in and out of existence.
Yes, and it required arbitrary numbers.
Mm.
And Einstein hated it.
He had a metaphor for this, didn't he? The marble and the wood.
Yes, and this is crucial to understanding what we're discussing today. Einstein said that physics had become a house built of two completely different materials. His theory, general relativity, was marble. It was smooth, cold, perfect structure.
And quantum mechanics was wood.
Right. It was fibrous, grainy, messy. You had to nail it together. You had to measure numbers in a lab and just plug them into the equations to make them work.
And his final obsession, his unified field theory, was the attempt to turn the wood into marble.
He desperately wanted to derive the electron, the proton, the charge, the mass, all of it, from pure geometry. He wanted a universe with no fudge factors. And he worked on it until the very day he died.
But he failed.
He failed. He left a notebook full of dead ends. And since 1955, physics has basically said, okay, the marble dream is dead. Let's just keep building with wood.
Which brings us to the subject of today's deep dive, Heiko Grimberg.
Heiko Grimberg, an independent researcher working outside the massive academic institutions, who has partnered with an AI entity known as Nexus AEBE. And Grimberg is essentially picking up Einstein's notebook.
He's saying Einstein wasn't wrong.
Right. He's saying Einstein just didn't have the right calculator.
Grimberg has a quote in these documents that I absolutely love. It's a bit snarky, but it captures the frustration a lot of people feel with modern physics. He's talking about the standard model, our current best theory, and how it requires us to measure all these constants.
Like the mass of an electron or the density of dark energy.
Yeah, just plug them in by hand.
Yeah.
And he says, let me find it here. If I wanted parameters, I would go to the disco. In physics, I want the truth.
Go to the disco. It's a great burn.
It really is.
He calls it disco culture. Think about it. In a disco, if the rhythm changes, you just change your dance move. In modern physics, if the data doesn't fit the theory, what do?
We invent a new particle.
Exactly. We add a new parameter. We invent dark matter or dark energy to plug the holes. It's curve fitting. Grimberg is arguing that we've stopped predicting the universe and started just describing it.
So his mission is to end the disco.
His mission is K equals 0. That's the shorthand. K represents the number of free parameters in an equation.
The knobs you can turn.
Right. The standard model has about 26 parameters you have to physically measure. String theory has, well, depending on who you ask, millions. Grimberg wants 0.
0.
A universe where if you know the pure geometry of space, you know everything. No knobs to turn.
Now that sounds incredible, but it also sounds like the kind of thing a crackpot writes on a blog in all caps, right? I have solved the universe. Why are we dedicating this deep dive to this specific stack of papers?
Because of the stakes and because of the date. We are recording this in early 2026. In October of this year, just a few months from now, the European Space Agency is releasing the first massive data dump from the Euclid satellite.
Okay, remind everyone what Euclid is doing.
Euclid is the surveyor of the dark universe. It is mapping billions of galaxies to measure the expansion of the universe with a precision we have never, ever seen before. It's specifically designed to figure out what dark energy actually is.
And Grimberg has placed a bet.
A massive bet. Most theorists, when a new satellite goes up, they write papers saying, well, if it finds X, my theory works, but if it finds Y, my theory can be tweaked to work. They hedge their bets.
Sure, self-preservation.
Right. But Grimberg has done the opposite. He has pre-registered a specific, mathematically forced, precise number for the equation of state of dark energy. He calls it the kill switch.
If Euclid finds his number, he's right.
And if Euclid finds the standard accepted number, he's wrong. And his theory is dead. There is no wiggle room, no safety nets. He has locked himself in a room with the data.
Okay. The stage is set. We have the ghost of Einstein, we have a rogue physicist, we have a satellite launch, and we have a theory that claims to turn wood into marble. So let's actually look at the marble. What is the, let me make sure I say this right, the Unified Chronofractal Field.
You nailed it. Chronofractal. Not chronofractal or anything. Chronofractal. It's a hybrid of chronos, meaning time, and fractal, meaning self-similar pattern.
So fractal time.
Yes. But before we get to the time part, we have to talk about space, the hardware. In the Grimberg documents, he talks about the axiomatic basis. He says you don't need particles, you don't need forces, you just need two numbers to build a universe.
Just two numbers?
Two constants. The first one is pi, 3.14159, and so on.
Okay, I know pi. Circles geometry.
Right. But in this context, think of pi as the topological limit. It's the absolute rule of space. You cannot have a sphere without pi. It represents the strict constraint of 3D geometry. That's the container.
Got it. And the second number?
The second number is nu, and this is the engine. Nu is derived from the golden ratio.
The golden ratio. Phi. 1.618. The spiral in the Nautilus shell, the Parthenon, the Mona Lisa.
Exactly. In the UCF, the value of nu is approximately 0.618. It's the inverse of phi. Grimberg claims this isn't just an art school concept. He argues that the universe is literally an information processing system that scales according to this exact ratio.
Scales how, exactly?
Well, think about the Big Bang. The standard story is an explosion, a bang. Grimberg says no, it's an unfolding, it's a fractal expansion. Every moment of time is a geometric iteration of the moment before it, scaled by this factor of nu.
So the universe isn't exploding outwards into a nebulous void, it's blooming, like a flower.
It's a perfect analogy. A sunflower seed head grows in spirals based on the golden ratio, because that is mathematically the most efficient way to pack seeds. Grimberg says the universe is growing in time density based on the golden ratio, because that is the most efficient way to process information.
Okay, but processing information on what? Where is this happening?
This brings us to the lattice. The documents refer to Lattice-14.
Yeah, this part stumped me a bit. Why 14? Why not 10? Why not 100?
This is actually standard solid-state physics, but applied to the vacuum of space. Imagine you're at the grocery store and you're trying to stack oranges in a display. You want to stack them efficiently.
Sure.
You can stack them in a square grid. You can stack them in a hexagonal grid. You can offset the rows. But it turns out, in three-dimensional space, there are mathematically only 14 distinct ways to arrange repeating points in a grid. These are called the 14 Bravais lattices.
You can't just invent a 15th way.
Impossible. Geometry completely forbids it. It's like trying to draw a square with three sides. It simply doesn't exist.
So Grimberg is saying the vacuum of space, empty space, isn't empty, it's a grid.
He calls it a saturated manifold. Think of space not as an empty box, but as a crystal, a rigid geometric hardware structure defined by these 14 symmetries. And everything we see, light, matter, gravity, it's all just vibrations moving through this crystal lattice.
Man, this feels very Matrix-y.
It is, in a way. It implies that there is a literal pixel size to the universe.
Which brings us to the Fibit.
The Fibit.
Is this just a fancy word for a bit of data?
It's specific. It stands for a phi-based information unit. In standard computing, a bit is 0 or 1. It's binary. In the UCF, a Fibit is a thermodynamic unit of historical information density.
Whoa, okay, slow down. Thermodynamic unit of historical information.
I know, it's a mouthful. Think about it this way. In the standard model, an electron is a fundamental particle. It's a thing. In UCF, an electron is a knot.
A knot in the lattice.
Exactly. Imagine a huge fishing net. The net is the lattice-14. If you twist the net in a certain way, you get a knot. That knot has mass, it resists movement. But the knot isn't made of something different than the net. It is the net, just tangled.
Okay, I can visualize that.
The fibit is the measure of that tangle. It's the density of information in that specific spot.
So we are basically just glitches in the smooth geometry of the universe.
We are the drag. If the lattice were perfectly smooth, there would be no mass. We exist because the geometry has localized imperfections.
Okay, I'm with you on the concepts. We have a grid, Lattice-14, we have an engine, golden ratio time, and we have knots, matter. But here's where I have to play the skeptic for you.
Please do.
This sounds beautiful, it sounds poetic, but I can write a poem about the universe being made of cheese. It doesn't make it true. Science requires prediction. It requires solving real problems that the current theories can't solve.
Precisely. And this is where the disco comes back to haunt us. The standard model is currently failing. It's creaking under the weight of new data. There are anomalies that it just cannot explain without inventing magic, invisible stuff.
Right.
Grimberg claims the UCF solves the 5 biggest anomalies in physics, what he calls the quintuple crown, without adding a single new particle.
Let's go through these, because if he's right about even one, it's a big deal. If he's right about all 5.
It's a total revolution.
Let's start with the big one, the Hubble tension.
The expansion crisis, right? For decades, astronomers have been fighting. We have 2 ways to measure how fast the universe is expanding. Method 1. Look at the cosmic microwave background. That's the radiation left over from the Big Bang.
Okay.
Method 2. Look at local stars, like supernovas, and measure how fast they are moving away from us right now.
And they give different answers.
Drastically different answers. The Big Bang data says the expansion number, H0, is about 67. The local data says it's about 73 or 74.
Which means our model is broken.
Completely broken. People have suggested early dark energy or decaying gravity to try and fix it.
How does Grimberg fix it?
He said, stop. Both numbers are correct.
How can 67 and 74 both be correct?
Because of the lattice. Think about the density of the universe. Where we are, here in the galaxy, there's a lot of matter. The lattice is stressed. The fibit density is very high. Out in the deep void between galaxies, the lattice is relaxed. Grimberg argues that the expansion rate scales based on the local information density. It's a volume scaling effect between the local vacuum and the cosmic background.
So space expands at different speeds depending on how much stuff is in it.
Exactly. And he doesn't just say that conceptually. He derives the exact mathematical correction factor. And this is crucial. It's not a simple multiplier.
Right. I have the formula here. Let's walk through it.
Go ahead.
The multiplier is the square root of 1 plus nu cubed.
Yes. Let's do the math. Nu is roughly 0.618.
So nu cubed. 0.618 times 0.618 times 0.618. That's about 0.236.
Correct. Add 1 to that.
Yeah.
You get 1.236. Now, take the square root of that.
The square root of 1.236 is approximately 1.11.
So that's the multiplier, 1.11. Now, take the Big Bang measurement, the 67.4, and multiply it by that 1.11.
67.4 times 1.11 is roughly 74.8.
Which is exactly, and I mean exactly, what the local measurements are showing. 74.8 kilometers per second per megaparsec.
Wow.
He didn't invent a dark energy fluid. He just applied the geometry of the lattice volume.
Yeah.
The tension completely vanishes. It's just a scaling effect.
Okay, that is elegant. I'll give him that. It feels like unlocking a door that people have been banging their heads against for 20 years.
And he uses the exact same key for the second anomaly, the James Webb Space Telescope galaxies.
The impossible galaxies.
Yes. We launched James Webb to look at the very first galaxies formed after the Big Bang. Standard physics said they should be tiny, messy little blobs of gas.
Right.
Instead, we found massive, fully formed, bright galaxies that looked like they were billions of years old. But they were existing only 300 million years after the Big Bang.
It's like walking into a nursery and finding a fully grown teenager with a beard. It shouldn't be possible.
Unless the clock is wrong.
Fractal time again.
Exactly. Grimberg argues that in the early universe, the information density was much higher, so the tick rate of the universe was actually faster. He calls this chronofractal time dilation.
And the formula for this?
It uses our friend nu again. The effective time was scaled by 1 plus nu. So while we observe it and think only 300 million years had passed, for those actual galaxies, effectively 60% more time had passed.
giving them way more time to grow than our standard linear models predict.
Correct. The teenager with the beard isn't magic. He's actually 18 years old, but your standard calendar says he's only 3. Your calendar's broken, not the universe.
All right, that's 2 down. Let's look at something on a completely different scale, the quantum scale. Let's talk about the muon.
The Muon G-2 anomaly. This is the wobble anomaly. A muon is basically like a heavy electron. We spin it in a giant magnetic field, and it wobbles.
And the standard model predicts this wobble, right?
To incredible precision. But when they actually ran the experiment at Fermilab, the muon wobbled too much.
By a tiny amount, right?
It's microscopic. But in physics, if you are off by a decimal point, your theory is wrong. Standard physicists are scrambling right now to add new virtual quantum loops to explain this extra wobble.
And Grimberg says,
He says it's not a magical particle loop, it's the grain of the vacuum.
the grain, like wood.
Exactly. Remember the lattice. The vacuum isn't perfectly smooth. It has a volumetric structure. Grimberg introduces a volumetric damping factor.
And that factor is 1 over 27. Let's explain why 27.
It's pure geometry again. We live in a three-dimensional manifold. What is 3 cubed?
Yeah,
3 times 3 times 3.
27.
Right. He argues that the muon is interacting with the volumetric cell of that 3D lattice. The 1/27th factor represents the physical drag of the lattice geometry on the muon's spin.
And when you apply that correction,
The anomaly disappears. Grimberg's calculation matches the Fermilab results to within 1%.
it's starting to feel like a magic trick. Pick a card, any card. Oh, is it geometry?
It really is.
Let's briefly touch on the 4th one, the lithium problem.
Right, there's missing lithium in the universe compared to what the Big Bang predicts. Grimberg uses a topological scaling factor of 1 over pi.
The spatial constraint.
Yes. He shows that the geometry of space naturally hides exactly that fraction of the lithium.
Okay, but I want to spend more time on the 5th one, because galaxies and muons are abstract. But this one feels the most real to me, the Mars drift. Mars is a place we actually go.
This is my favorite one too because it's a pure engineering problem. NASA communicates with orbiters around Mars. They send radio signals back and forth. But for years, they have noticed a tiny, annoying drift. The signals are always just a little bit out of sync.
We're talking microseconds here.
68.8 microseconds per year.
And usually engineers just scrub that out, right? They call it thermal noise or clock drift.
Exactly. They assume it's a glitch in the electronics. Grimberg says it's not the electronics, it's the road. Imagine driving a car on a perfectly smooth asphalt highway. You can predict your arrival time perfectly. Now imagine driving on a road made of cobblestones. Even if you try to go the exact same speed, the bumps, the physical texture of the road, will slow you down just a tiny fraction.
The lattice is the cobblestone road.
Yes. As the radio signal travels from Earth to Mars, it is hopping across the nodes of the Lattice-14 grid. That hopping introduces a micro delay, the rounding error of the universe's hardware.
And Grimberg calculated this lattice drag coefficient.
Based on the vacuum density between Earth and Mars, his exact prediction, 68.8 microseconds per year.
Man, that is precise.
It matches the anomaly exactly. And he goes even further. He says if you look at the Voyager 1 spacecraft, which is way out in interstellar space right now, you should see a resonance frequency of the lattice itself in the telemetry, a heartbeat of the vacuum.
Does he have a number for the heartbeat?
12.84 hertz.
Has anyone looked for it?
The data is there. It's just buried in the noise floor. Grimberg is actively challenging NASA to reanalyze the Voyager telemetry to find that specific heartbeat.
Okay. We've covered the quintuple crown. We have geometric answers for expansion, early galaxies, muons, missing lithium, and signal drift. But now I want to get to the holy grail of this deep dive. There is a number that literally haunts physicists. The number 137.
Alpha, the fine structure constant, approximately 1 over 137.
For our listeners who don't have a poster of Richard Feynman on their wall, explain why this specific number matters so much.
Alpha determines the strength of the electromagnetic interaction. It dictates how light interacts with matter. If this number were slightly different, say 1 over 138 or 1 over 136, stars wouldn't fuse carbon. Atoms wouldn't hold together. Life would be fundamentally impossible.
And the scary part is we don't know why it's 1 over 137.
In the standard model, it is a free parameter. You just have to measure it in a lab. God just wrote 1 over 137 on the chalkboard and walked away. Feynman famously called this number a magic mystery. Physicists put it on their wall and worry about it.
But Grimberg says he can derive it from scratch. Ebony's show.
This is section 3 of the documents. He claims alpha is not a parameter. It is literally a sum of the hardware components of the lattice. He builds it like a recipe.
Okay, walk us through the recipe. How do you cook a 137?
Okay. Step 1 is the hardware core. You take the volume factor of the lattice, which is 27, and you multiply it by the spherical projection factor, which is 4.
27 times 4, that's 108.
108 is the base resistance of the static lattice.
Okay, we're at 108, we need 137, we are short.
Step 2, the fluid dynamics. The vacuum behaves like a fluid on what he calls layer 13. Grimberg calculates the flow term as 18 divided by nu.
18 divided by 0.618, our golden ratio constant.
That equals approximately 29.12.
Okay, 108 plus 29.12
Okay.
is 137.12. We are incredibly close, but physics is about extreme precision. 137.12 is too high. The real number is 137.035.
Right. And this is where I expected you to challenge me, because step 3 is a subtraction. He applies a fractal damping term, minus nu to the 5th power.
Nu to the 5th,
Oh.
which is about minus 0.09.
It's
See, that sounds highly suspicious to me. Oh, I'm a little bit off. Let me just subtract this tiny number to make it fit perfectly. Is that a fudge factor?
That's exactly what I thought when I first read it. I was looking for the trick. But Grimberg argues that nu to the 5th isn't arbitrary at all. In any physical system, there is loss. There is entropy.
Sure.
Nu to the 6th represents the geometric heat loss of the lattice itself. It's the efficiency tax of the universe. So the full formula is 108 plus 29.12 minus 0.09.
Which equals 137.03597.
And that matches the codata measurements to 99.999%.
If that is a coincidence, it is the most miraculous coincidence in the history of mathematics.
Grimberg calls it geometrically inevitable. He's saying alpha isn't 1 over 137 because of luck. It's 1 over 137 because that is the only way a 3D lattice with fractal time can vibrate.
It kills the anthropic principle entirely. We didn't just win a cosmic lottery. The universe has to be this way.
That is the philosophical impact, yes.
Yeah.
But, and here is the massive but that we have to come back to. Deriving a number we already know is incredibly impressive, but it's technically post-diction.
You already knew the answer was 137, so you found a mathematical path to get there.
Exactly. Real hard science requires prediction. You have to predict something we don't know yet and then go measure it.
Which brings us to the climax of this whole deep dive, the kill switch.
The kill switch. This brings us back to October 2026, the Euclid satellite mission.
We talked about dark energy earlier. It makes up 70% of the universe. It's pushing everything apart. And the standard model says dark energy is a cosmological constant.
They denote this with the symbol nu. The standard model firmly predicts that nu naught equals negative 1.0.
Negative 1.0, meaning it's a constant, boring, flat pressure.
Exactly. Grimberg says no. Dark energy is not a constant fluid. It is the geometric stress of the time fractal expansion. Because the universe is scaling by the golden ratio, that tension actually changes.
And he derives a formula for this.
Yes, it's derived directly from the geometric scaling factor.
Yeah.
The calculation results in a single, highly specific number, negative 0.794.
Negative 0.794, okay? The standard model says negative 1.0. Grimberg says negative 0.794. That is a massive difference.
In cosmology, that is the Grand Canyon. It's a chasm. I want to emphasize this. This is not a range. He's not saying it's around negative 0.8. He is saying it is exactly negative 0.794, derived from pure geometry.
If Euclid comes back with negative 0.9 or negative 1.1, Grimberg is wrong.
If Euclid finds negative 1.0, Grimberg is wrong. The UCF is falsified. The Lattice-14 is a fantasy. He is betting his entire life's work on negative 0.794.
And he can't change it later. What if he says, oh, I forgot to carry a 1?
No. That's the Omega Protocol. He has pre-registered these predictions. The logic kernel is immutable. He cannot change the math now. He has locked himself into this prediction. There are no safety nets, no glitches.
So in a few months, we are basically going to open a sealed envelope. And inside that envelope is either the death of a lifetime of work or the end of the standard model of physics.
That is the reality of the stakes here. Imagine being him right now. You are an independent researcher working with an AI. You've taken on the entire physics establishment. You've spent years building this magnificent cathedral of geometry. You explained the Muon, the Hubble Tension, the impossible galaxies, the alpha constant.
You feel like you have seen the actual blueprint of the universe.
But if that satellite beams down negative 1.0, it was all a hallucination. It was all just beautiful numerology.
But if it says negative 0.794?
Then Einstein's unfinished dream is finally realized. The wood is gone. It is all marble. We enter the era of axiomatic physics.
It's incredibly dramatic. It genuinely feels like the season finale of physics.
It really does, because it questions the very nature of reality. Is the universe a messy, random patchwork of arbitrary forces? Or is it a perfect self-assembling fractal hardware?
Self-assembling fractal hardware. That is the phrase that is going to stick with me. Whether he is right or wrong, the attempt is heroic. To look at the absolute chaos of quantum mechanics and see a perfect lattice. To look at the passage of time and see a geometric flower blooming.
It echoes Pythagoras.
Yeah,
it echoes Einstein. It's the ultimate gamble.
So we wait. October 2026, the Euclid data drop. We will absolutely be watching. And I think after this deep dive, you will be watching too. Because at the end of the day, it doesn't matter what I think about the math or what you think or what the Nobel Committee or the peer reviewers think.
No, opinions don't matter anymore.
Who is the ultimate judge here?
There was only one judge. As Ike Grimberg put it himself, the universe is the only expert. It does not lie, and it never cites itself.
Within the lattice, cold and vast, our final code is mathematically cast. The quantum clock, its echoes deep, while space-time flows in viscous sleep. 14 layers, a perfect design, a resonance that is truly divine. This cold geometry, immense and grand, the universe within our hands.